So I'm Patrick Stanko, and I'm going to just go back over the data reduction spreadsheet that was presented earlier. We've sort of added some edits to it to hopefully show what we are wanting you to do when it comes to the data reduction, and matches to what has been changed to the spec 3.02. As previously talked about before in the data reduction steps, basically you're going to abstract the data from the text or CVS files from SFlow tool, convert the SFlow data into megabytes per second with timestamps, combine the SFlow data with the power data on the 10-second intervals, identify the workload start and stop times, use linear interpolation for the SFlow data to match the power data if it doesn't match up on timestamps, and generate the 30 metric points needed for stability and the metric itself. Then you will do the stability of validation and generate the metric. So there was some requests to have the spreadsheet that I presented in the March presentation. So I've updated the spreadsheet so it contains 9 tabs. The first 2 are copyright disclaimer. The README tab has the steps required for data reduction. The SFlow data is where you would put in SFlow data. Power is where you put in power data. The combine tab is where you combine all the data. Pull out the particular test. The test that I pulled out was the VDA test, and the particular load point was VDA 10. We'll go through that here in just a second. So again, following the flows, actually, let me see if I can do this. If you look here, here's the spreadsheet. Again, here are the tabs that I was just talking about, the copyright disclaimer. The README tab, basically pulling out the steps for data reduction and which tab is used for that particular step. So here's the SFlow data that we had before as an example from the March meeting. You can see me here. We can find the MIBs per second and the calculations that I was using to find out the MIBs per second from the raw data over here in column A. So let me come back up to here. Okay, so that's where we were at. So we were using the tabs for the SFlow and the power data. We pulled the data from the SFlow text file that was provided to me, and the power data we put in here. And the example was from a Yokogawa on a 5-second readings. Again, generating 10-second averages that we just talked about. So I was keeping every other point. So here was the SFlow data that we had here, where I was calculating the MIBs per second using the Unix, and then calculating to Microsoft Excel timestamps for using in the spreadsheet, and I broke out the hours, minutes, and seconds. Here's the power data, which is the raw data that we had here, and it's in every 5 seconds. So again, I just averaged the 2 points together, the one previous and the current time sample, to get an average, and I was keeping every other data point for the 10-second averages. And then I'll copy the SFlow data and power data into the combine tab, trying to match initial starting timestamps, and then find from the log points, find where the start and stop points are. So So the combined stamps here is that we can have the S-flow data and the power meter data, and then I used just an if statement to find out if it matched and see that the timestamps are starting to deviate. Then I'm going to pull out the desired workload, and I put an example as the VDA. That's why it was the VDA Raw tab. I just put that in there, find out where the start and stop points are, and update the graph so that you can see the whole run in one example. Oh, come here. So here's the VDA Raw data again. I put a marker in here to where I can see where we started, the start of the VDA test. There's a warm-up period. There's a VDA, this is load point 1, where it actually starts and finishes, and we start load point 2 setup. And just the graph here, and that is showing it here so that you can see the different load points. So that we have load point 1 up to load point 10. It's required by the step. So I'm going to pull out a particular load point, place in the VDA 10 tab, review if the timestamps are different, and use interpolation to linear interpolation to match up the performance data to the power data. And I need to make sure that the points are not more than 10 seconds off. We'll review that in the tab here. It will then calculate the stability and the metric, and so you can review that data in the last tab. So pulling in the particular load point start and stop times, seeing that the timestamps are different here, using a linear interpolation to for the performance. The equations are noted above, and then generating the metric from that point with the interpolated data versus the power data. You do need to, I'm using here is the seconds, so that's all I looked at was like at 33 seconds, 43 seconds, 53 seconds. That's what this calculation is based off, is just the seconds. You can see here at this particular point in time where the timestamps do match up, you would just not use linear interpolation. You just need to make sure that the performance data is copied directly over into the of the performance data, and then start interpolation again. We calculate the metric, 30 metric points. You have your W and K from the spec. You can calculate your moving average here and make sure that it is no longer, there's not a 5% change. You calculate the linear square fits feasibility test. Make sure it's not within 5% change. Then you're using the 30 metric points you just calculated to calculate the metric average. So that is all that I had in the spreadsheet update that we added. Again, you can see the equations above the columns where I'm using the calculations and how to do the data reduction and the steps for that. Is there any questions? Any questions about the spreadsheet, the process? Everybody's on mute.
Patrick, is this the same spreadsheet that we worked with back in March? Or?
It's the same spreadsheet we worked out with March, just adding up the, we added in the equations. Back in March, we went ahead and did the 0.1 and 30 instead of the 5 and the 5 points that the spec called out, which was changed with 3.02. So it's basically the same worksheet, except it's got more of the equations are set up here. So you can see what the equations are without having to go and actually look at them in the Excel spreadsheet. So there's a question that is why are we doing this with the linear interpolation? So SFlow, which is getting the data from the switch, may be busy and actually move a second or two out when it has a chance to send the counters to the collector. So that's where we're getting off on the difference on the timestamps. And to match up again, so that we're looking at actually what we're expecting performance to be versus the actual average of the power, we had to use linear interpolation to match that up. So that's why we're looking. That's why we're having to go through this process of matching up and using linear interpolation on the timestamps, is because the SFlow data timestamps are moving, which you can see here. And it wasn't just an easy way of just combining the two data sets and calculating the equations. Any other questions, concerns?
I believe before there was a question of if there's a warm-up period for calculating your metric, because with the block you have the warm-up where you get your stability all dialed in, and then you start with the 30 points after that, but here we're limited to 30 points.
So I will attempt to answer that question, and then Don will follow up, I'm sure. So you have a warm-up period here. If we look at the VDA Raw data, right, we start the VDA test. There is a built-in warm-up period in SpecFS 2014. So there is a warm-up period that you're getting stability, and then you do start the test. So you have it built into the way that the SpecFS 2014 works, that there is a warm-up period, and then that's why we're just taking the 30 points from the load from the test. Is that correct, Don? If you can unmute.
Can you hear me?
Yes.
Yes, you got it perfect. It's 30. There are 300 seconds of warm up followed by 300 seconds of measurement, the actual run phase, and so you have your warm up.
Okay, so we're not calculating any metrics on the warm up though. We're just saying that it's there.
Correct.
Okay.
Any other questions? If not, I'll turn it back to you, Wayne.